These are the 10.1 notes, Law of Sines, page 7. You will notice that my page 7 looks a little different than yours. As I was working through the answer key, I realized I meant to move example 9 to the next section because that is more easily solved using law of cosines. We can solve it at this point, but involves a lot of different triangles, and it's not even using law of sines. So we're not even going to worry about that right now. We are just going to focus on example 8. And so here's what we've got. We've got 2 radar stations located 20 miles apart. They each detect an airplane between them, and the angle of elevation measures by the first station is 35 degrees. The angle of elevation measured by the second station is 15 degrees. We want the altitude of the aircraft. And so here's the thing. That altitude makes a right triangle. Awesome, but that 20 miles covers both of those triangles, so that's not incredibly useful. I have 2 angles and a side between them. So we could use law of sines to solve the triangle. Keep in mind that would be the outside parts. We'd still need to figure out how to find that altitude, okay? In the meantime, though, I'm going to go ahead and solve the triangle. I'm going to see what pieces I can find that maybe give me a hint as to how I can go about and solve this. So first things first, I'm going to find this angle at the airplane. I've got the 2 other angles, so I can find that one. So I got 180 minus 15 minus 35. That gives me 130 degrees. So I know this angle is 130 degrees. Okay, now I have this angle and the side opposite it. So I've got this angle C and the side opposite. So I can set up and use law of sines. I am going to go ahead and find, I don't know, does it really matter? You know what I'm going to do first? I'm going to label this like I would any other triangle. A, B, C, A, B, C, just in case that helps. So yeah, I'm going to go ahead and find C. And so C over the sine of C equals, what have we got? B over the sine of B. C over the angle opposite that side is my 35-degree angle. And then I've got the length of side B is 20 over the sine of 130. Keep in mind with these kind of problems, there are always going to be multiple ways to go about solving them. So if yours doesn't, or mine doesn't match yours exactly, that is okay. And if you have questions about what I did or what you did, don't hesitate to reach out and ask. So we get C is approximately 14.975 miles. I'll put that up here. Okay, so now I have got 2 sides. I have this side, I have this side, the angle between them, so I can find the area of the whole triangle. And I'm looking at that because I know this bottom side, the B is 20, and my altitude is perpendicular to that. So I can go back to the high school definition for area, 1/2 base times height. If I have the area and the base, I should be able to solve for the height. And I can find the area right now using 1/2, how do we label this? BC times the sine of A. So 1/2, B is 20, C is 14.975, and angle A is that 15-degree angle. I get the area equals 38.758 square miles. I am not going to round any more than that right now. I want to be as precise as possible. So now let's go back to our high school definition for area. Area equals 1/2 the base times the height. Well, we know the area. 38.758 square miles. That has to equal 1/2. My base is this 20 miles here. And we're trying to solve for the height. H is my only unknown. So 38.758 equals 10H. I'm going to divide both sides by 10. And my height is 3.8758. We're going to go ahead and round that to 3.9 miles. So that airplane is 3.9 miles above the surface of the Earth.